So good day once again, everyone. My name is Boyo, founder here at MBKonsult. Um, I really appreciate everyone that has taken the time out to join us on this lovely Saturday afternoon where I am. I don't know what it is, where you are, but appreciate you. So we had the introduction to data analytics part one last week, and my friend Lade Shelle, who is here, um, wonderful guy. He knows his crafts. I respect him a lot. And, I just can't appreciate him enough. And so I'm going to have him to continue from where he stopped last week. I don't know, maybe he would want to do a recap of stuff from last week. That depends on him. And then today we'll also have the, um, how do I say it now? We'll have the privilege of him actually solving a use case so that it's not just, we are talking theory here, but hopefully, he will take us into the world of let's see how this thing actually works. So without much ado, please join me in welcoming Lade Shelle. Thank you very much, Lade.
Thank you so very much, sir, Mr. Michael. I really do appreciate it. I'm not as much as you have introduced me today, but I will do my best to facilitate this session.
I'm,
Again,
I'm, I'm sure your best will be more than good enough.
thank you everybody else for joining in. I really do appreciate your time for joining us. The last session that we did facilitate, we discussed on things about what data is, what data analytics is, and the steps in the data analytics process. Now we're going to do a part two of our introduction to data analytics, and then we can continue from there. So my name again is Lade Shelle. I do work for the City of Edmonton, and yes, let's get right into it. Thank you so much, Mr. Michael.
Welcome, sir.
So the outline for today is we're going to discuss the data ecosystem, data storage as a topic, data pipelines, what is big data, and careers in data analytics. At the end of this session also, I'll do a demonstration using Tableau to show how data visualization goes. So yeah, we can move on to the next slide. Now, the data ecosystem. The data ecosystem refers to the various components that interact with one another in order to produce, manage, store, organize, aggregate, analyze, and share data. Don't worry about this definition. I mean, I guess this slide, this presentation will be shared along with you, but I will get into what this means. So, share data, and this includes the software and the hardware tools and the people who use them. Basically, so if you work in any organization, in any industry, in whatever business it is, what the data ecosystem is all of the processes, all of the people, and all of the steps involved in a data lifecycle. So let's say you work for finance, for instance, you have all of this transaction data. So how you collect that data, that's the term for produce or create. So people do transactions, right? They use your financial institution to do transactions, whether it's card, whether it's online, whether it's, let's say they call in to the customer service to do a bill payment, right? You're creating data. That means somebody has interacted with your organization, and that is data that you can store somewhere. Typically, all of this data is stored in a database, right? It's inside some sort of transaction database. So the data ecosystem, let's use the finance example, includes where you get the data, how that data is transported into your organization as a finance institution. So all of these transactions come to you, and then all of the people that manage this data, they sort it, they store, they organize, and aggregate it, and then analyze for business purposes. That would be the entire data ecosystem, right? So let's talk about some concepts that are around the data ecosystem. Number one would be data structure. Now, let's not confuse the data structure with data storage, and I will tell you the difference down the line when we get to data storage. But data structure refers to the methods used to keep and organize data. Now, examples of common data structures include arrays. Arrays would be the most common one that we can use because basically that means you are storing data in rows and columns. Oh, okay. Sorry. Before I continue, does anybody have any questions? Okay, no questions there. So structures, and again, we'll get to data storage, but structures is like how the data is stored. So arrays would refer to like columns and rows. So that would be your tabular structure. So what is on row one, what is on column one, that sort of data, right? Linked lists. So you can also have data that is organized or is kept in lists where you have a list of objects. So like pineapple, you say fruits, and then you say apples, pineapples, oranges, lemons and limes, right? And then you say under the list for apples, you also have other types of apples, green apples, red apples. That would be sort of a linked list, because after you have that list, under that list, you have other lists that are linked to it. Stacks, queues, trees, and graphs. These are just other ways that you can express data structures. And a commonly found example for data structure is your DNA. Your DNA is a double helix, right? So your DNA, and that's not listed here as a data structure. I'm just saying, like in general, for the purpose of data, it does store information about who you are, right? It stores information exactly to the T about who you are, and that's how they're able to identify you. It's because it's a double helix, and it has a structure, and it has the way the proteins are organized. So those are data structures. It's just a way or a method that is used to organize and keep data, right? Now, the next thing we'd want to talk about is data storage. So data storage actually refers to the software and the infrastructure that is responsible for those methods that we just discussed earlier. So an example would be a data lake, where a data lake is used to store all manner of information. We'll get into it down this presentation. And then there's a data warehouse. So a data warehouse basically is where all of this data is stored in form of, it's stored structurally in forms of tables and the likes, right? So it's more of a place where you extract data for analysis and for machine learning purposes. We'll get into that down the line as well. So data sources, where the data originates, data processing, how that data is transformed into a usable format. So we have all of this data that comes in, let's say temperature, right? We have all of this temperature for the day, but we need to know how that all of this temperature for today would affect next year, for instance. So we process all of this data, we look at all of the different variables, and then we try to figure out what the temperature would be for next year. So that's an example of data processing. Another example would be like in video games, for instance, right? You have all this raw data that comes in if you are playing video games. And then the developers, they need to figure out where this person is in this whole ecosystem, what this person is playing, what this person is doing, right? And then they need to process it. Now, processing means how do we figure out who is number one, who is number two, who is number three in this video game? That's an example. So data processing, very important to the data ecosystem, and it's a very important concept to the data ecosystem. Sorry, Mr. Michael, can we go next? All right. So we're still continuing in concepts in the data ecosystem. Data analysis. Now, that means we're taking all of this data, we're exploring it. Hopefully, we're extracting it because that's the only way we can get it. So, exploring and extracting insights from this data means we have now collected all of this data. And again, we can go to the example of video games. So, we have all of these millions of people playing, let's say, Temple Run. And we need to know where all of these players are at any point in this game. And also, we need to be able to measure who is the top scorer for playing this game, right? So that's data that we've collected. That's data that we've extracted, and we have to do all of this computation on the fly. So data analysis involves exploring and then taking that data and then extracting insights. And that insights might be who is the top player, who should we give the rewards to, that sort of thing, right? But we can also look at it in simple terms. We can look at it in the terms of, let's say, the city, right? And then we have all the sensors on all these buses. And we are extracting all of this data, but we need to know which of our, or how many of our drivers are not following the course. How many of our drivers are stopping too early, right? That's what data analysis will do in the data ecosystem. Data visualization, and this is what we're going to do later in the day. There's a demo using Tableau. Data visualization refers to presenting data in a clear and understandable way. Basically, so with charts, with stats and different types of charts, right? So maybe it's a bar chart, or maybe it's a pie chart, or maybe it's a line chart. So making sure that all of this data is being able to be communicated in a clear and understandable way. So for management, for everyday users, for academics, right? So you want to show them this is all of the research that we've done. This is all of what we've achieved with the data. This is all the analysis. And here's a way that you can view it, right? And I'll just stop briefly to allow anybody go here for a question, 1, 2, before I continue. Okay, no questions. So another concept in the data ecosystem is data governance. Now, this would be an entire team in an organization that is responsible for ensuring data quality, security, and compliance. And what do we mean by that? That means there's a team where they look at the data, they're able to classify it, right? And then they're able to determine who needs access to all of this data they've classified. And then they are responsible for ensuring that compliance is met. So, for instance, we look at, let's look at city again. The city of Edmonton, we have a lot of data, right? There's data that should be publicly available. Let's call it classified data A. So everyone should have access to it. And then let's say there's also classified data B, where it's only the City of Edmonton staff that should look at it for privacy and security reasons, right? So that's their job. The data governance team would classify this data into, let's say, class A, class B, class C, and ensure that nobody else is able to have access to data that they shouldn't have access to. So let's say public A, classified data A, everybody in the city should be able to look at it, should be able to view it. And let's look at examples would be census numbers, right? Population, right? Things around mapping, so where places are laid out. Now, you might also have confidential information or slightly confidential information, which is personal information about the employees that work at the City of Edmonton. So things around managing uh, classification, access to data, and the security is what data governance covers. Now we can also move to people and processes, and that refers to all of the processes in your data lifecycle. So from the day you create that data or you acquire that data to the point where you delete the data or you retain the data for further use. So that would include all of the process approvals, requests. People would be like the data scientists, the data analysts, the data engineers that are responsible for getting all of the data across to the different business areas of an organization. So people and processes, that also is part of our data ecosystem. We can move to the next slide. So data storage, and I wanted to make that different again from data structures. So data structures it does refer to how the data is stored, but the data storage refers to where it's actually kept. Now, data storage, we can have three different types. We have databases. I mean, so this is organized collection of structured data often used for specific purposes. Now, let me break that down for us. Databases would mean, let's say we are keeping records, and this is tabular, right? That's the only way databases are stored. Is tabular records, meaning rows and columns. It can be something as simple as what are all the temperature readings for all the different hours of the day, right? Or it could be something in your organization that you can relate to, like HR, right? So HR will keep databases. And I think a lot of people think databases as Oracle or maybe Microsoft or whatever databases are out there commercially available, but those are software. They're responsible for keeping that data. They're not the actual databases. A database would be like, so HR keeps information of personal things about an employee. So the person's first name, last name, marital status, their gender, um, their SIN number, so security, right? And then they also keep a different table where they have like payroll information, how much this person earns, what this person is in this organization. And then when you put all of those tables together, you can now structure it and say, this is the HR database for this organization, right? So it's a collection of structured data often used for specific purpose. And this exact example I used was for HR. Now you could have an accounting database that is saved in Oracle. It might be saved in Microsoft SQL, and it would be the same thing. It would be, all right, accounting. This is our inventory. This is a table of our inventory, and this is another table that shows all that we've sold, and this is another table that shows the profits and where in the different regions, right? So that would be a database. I'll pause again here just to see if anybody has any questions with regards to what we're talking about.
Yeah, Lade, if I may chime in here. So
Mm-hmm.
I guess so. I like the way you try to give that example of collection of structured, or I would also use the word related data. You use the
Mm-hmm.
example of HR, right? Personal information, payroll information, and we collect that together, and then that data cannot just sit in limbo, right? It needs to sit in an environment, which is what you are calling the database. Because I feel
Mm-hmm.
like when people hear about data analytics, and especially the way the world has gone, now people just hear Tableau, Power BI, and people just don't even know what's happening behind, right? That those applications are just visualization. But where is the data itself? Where is it sitting? And that's what you are saying here, that that data is sitting in a database, and then there are different databases, right? And that's why,
Mm-hmm.
when you look at JD, so for those of you that are here and you are thinking of, oh, I want to get into a career in data analytics, and you now see on a JD, they say knowledge of MS SQL, which is Microsoft SQL, structured query language, or Microsoft database, or say, for example, MySQL, or say, for example, Postgre database or MongoDB. So those
Mm-hmm.
are databases by technology. There's Oracle as well, right? There are so many of them. And so that's where you now start asking yourself the question. But for data visualization, you don't necessarily need to understand how the database really works because you are just working with the data. But I just want people to understand that when we say databases, that's what we are talking about, that data needs to reside within a database application, which is what Lade is talking about here. Thank you.
Thank you so, so much, Mr. Michael. And that is exactly hitting the nail on the head. Basically, he has made the distinction between what is the software that you use to save the database and then the definition of a database itself. So, like he said, you can have HR where the tables will be personal information and payroll, and then that would be stored in a database like Oracle or MS SQL or MongoDB or whatever it is, the software it is as a database. Now, under the data ecosystem, we also look at, as in under data storage, we look at data lakes. Now, it's a repository for storing large amounts of raw data in its native form, often used for diverse analytics. So it's basically if you have and the analogy is in your house, you have somewhere where you collect all of your data before you now start to process it, like a mail room, right? So basically, it's like let's keep all of our data here. This is where we store all of our data. And then when we figure out whatever use it is going to be for, then we deploy it. So a data lake would be able to store like multimedia, for instance. It will store documents. It will store tables and the likes, right? It's just a general place to keep all of the information about a business unit, about a business organization, right? Where it's not particularly for any use, but you have a future use someday in the future. So I can't right now think of any use cases, right? But let's say a bank, for instance, and a bank would have a data lake where they store um, customer transactions in one place. They would also store CMS information. So that's basically customer management relationship, CMR information. So basically, we had this interaction with this customer, right? And we're going to store all of the things that we said between us and this customer because we don't know when we might need it for some future use. So that would be like a data lake. That would be where you store all of such information. It's basically an aggregation of all of the information that your business unit gathers and is able to keep and is able to retrieve in one place in its native raw form. Now, from there, you can now start to pick it out and say, these are things that we need for analysis, or these are the things that we need for a machine learning job, or these are the things that we just basically, we haven't figured it out, but we will keep this data until we know what we want to do with it, right? So that would be data lakes. So you can keep things like pictures, things like videos, things like text information, right, in data lakes. Now let's go to data warehouse. Now data warehouses are more structured. So it's a centralized repository of structured processed data optimized for analysis and reporting. So let's say you are a retail outlet, right? You have all of your data in your data lake. You've collected things like surveys. You've collected things like videos of people coming into your store, right? You're recording things, snapshots, everything. So that's your data lake. That's where you keep all of this data regarding your business transactions. But your data warehouse is where you keep all of the data in a structured, processed form, and it should be used for analysis and reporting. So basically, it should be in tabular form, whether it's long or wide column or short column, right? Basically, what it is, and I will use a financial institution, for example. So a financial institution might receive a lot of transactional data. Amazon would receive tens of thousands of transactions per minute, for instance, but they also won't keep all of that information for analysis and reporting anywhere else but inside a warehouse. So all of that transaction will go into some place, and then they will replicate all of that information into a data warehouse. And why is this important? A data warehouse is important because you need a place where you are not directly interacting with your main data sources and affecting the performance. So example would be, again, like a bank, right? So a bank will have a database where they have all of these transactions coming into, but they also want to do some reporting, and they also want to do some analysis on that data. Now, they won't keep those two things in the same place, right? So what they would do is they will replicate all of the data that they have from all of their real-time online transactions, and then they will create a warehouse. And that's the definition of warehouse. It's a centralized repository where they will take all of the data that they've retrieved and produced in everyday daily operation, and they will keep it in some place where they can use it for analysis and reporting. It might be a lot to take in, so at this point, I also want to take questions so I can explain further if I didn't quite explain it well enough.
Folks, you are not asking questions, so don't start calling Michael Boyo after the call. Okay. Um, just to buttress what you are saying, Lade, and it fascinates me. I've always been a super user of data. At best, I've not really gone into. I've worked closely with database administrators, but I've not functioned as one. So I have an idea of what they do, and just to keep things a bit so that people can relate, right? So I think database is clear. So we all know the fundamentals of data, like you have rightly said, a retail outlet that's a conglomerate. So various touch points, right? Could be at the store, could be online, e-commerce website, Shopify, whatever. It could be in a shopping complex. You go in, a walk-in customer, they capture your data. All that data goes into a database. It's real-time processed, as it were. But we can't be massaging that data while it is accessible by the front end users, right? We can't do that. So that's where you now say, oh, okay, let's put all this data somewhere
Mm.
where we can process it whenever we want without affecting real time users of the data, right? So you ship them up
Mhm.
into a data lake. It's predominantly unstructured. You just use it for specific purposes as you deem fit. But when you now decide that, you know what, I think we fully have a grasp of what we want to do with this data, then you now want to start pulling them into a data warehouse where it now becomes structured and is now reusable by your users in that they will now be more like on demand. Okay, what do you need? Should we give you access to this data? Maybe the CEO wants to be able to see a particular data set that shouldn't be available to anybody that is not within top level management. And then that can now be exposed to the CEO or senior management so that they can use that data. Am I still on track, Lade?
Yes, sir. That's
No.
in fact, I wish I could give you some sort of award for
No, no,
summarization.
no. Then
But
uh because there are a lot of people here who have gone through a Salesforce training, and I
mm,
want to bring it home to them. So you know how Salesforce has recently launched the data cloud. It's always been there. It used to be called CDP, the core data CDP, core data. I can't remember what CD, core data platform. Yeah. But they revamped it, made it cloud-based, and they call it data cloud. Now,
mm,
question for you guys, and it's not really a question I'm looking for an answer. That where do you think all that data that Salesforce claims to say it's in data cloud? They will tell you if you are using that data in Sales Cloud, Service Cloud, whatever cloud, it's not sitting in that cloud. It's sitting in data cloud. So the
mm,
question is, where is data cloud sitting on? Because it can't just sit in limbo, right?
mm,
Now, data cloud is sitting on a data lake. Now, so what's data lake? So there are platforms or data lake applications that are sitting out there, predominantly cloud-based, which is just, in very simple times, you could say databases of databases,
mm,
right? That people can now buy. You have data lakes as a service. So, case in point, for example, Salesforce uses AWS as their cloud um, provider. So they use AWS data lake to store data, which we are now saying is data cloud. There are other, data lake applications like Snowflake, like Databricks, right? That someone like Philip has worked with, and there are other ones. There's also Azure Data Lake. So what has happened is that mostly all the cloud-based service providers, so Google, Oracle, Microsoft, they all have a semblance of a data. Because look at even, okay, let's bring it home. Your Gmail, where do you think all your emails are sitting on? Where? Okay, they give you 15 gig for free in your email, and they say you can buy 1 terabyte of. Where do you think all that data is stored? Where? You think it's stored in somebody's basement? No, it's in the cloud, but there's a data center somewhere. So don't get me wrong. At the end of the day, everything ends up in a physical machine, even with all the data, all the cloud that we're talking about. At the end of the day, there's a data center somewhere, right? But what we're trying to say is that you don't need to understand the nitty-gritty of all of these. And there are the same way you have software as a service, the same way you also have data lake as a service. So you can decide to outsource that service to a provider, and they could actually give you data that you may need. You ask for to say, well, I need data on this particular subject or whatever. Or you can ship your data off to them, and they take care of all the tech stuff to ensure that your data is safe, is secure, is accessible, is real time, online, 99.99% uptime. It's all going to be on them. And all you need to do is just to access your data. So I hope that has been helpful for folks. And thank you very much, Lade.
thank you so much, Mr. Michael. In fact, I couldn't have explained this any better. There's no way I would have. So I really do appreciate that's a masterclass in data lakes and data warehouses. Um, any questions before we move on? All right, so let's get into Okay, sorry, Adirunke, she actually had her hands up. Please go ahead.
Thank you very much, Lolade and Michael Boyo. I think the two of you just clarified a few things for me because I was almost like I wasn't drifting off, but I was like, where are we here now? Because it was now sounding a little techy for people, some people like us. Now, my question is this, and I appreciate the explanation. So, lake is like a dam, put everything there, I'm
Mhm,
using layman's terms for myself now. Put a dam, put it in a dam, a container, and then if you want to process it, take it some out of that container, put it in your pot and start cooking. But make sure your raw
mhm,
materials are still in the dam, right? So that if you want to revert to the old version, you can always go back and retrieve. I think
mhm,
that's what I'm getting. Now, this is the
mhm,
question. Now, I work in health sector, and I so I generate my own data, but it's not like this kind of pool of data, this big data that you are referring to in the likes of City of Edmonton and what have you. This is where I'm going. So my own data, my numbers, they sit on Excel. So I use Excel. I use it to do my day to day. So how at what point would you say I would transition to, and again, this is just me thinking proactively into the future because I want to scale my business, right? At what point would you think I will need to start damming and then, going through all those processes? Because using Excel for me is like, okay, just gets the job done. But at this stage, I want to scale. Would you think this kind of information or knowledge I'm acquiring at some point will be useful to scale? And if yes, how can it be used? I don't know if that makes any sense.
Thank you so much, Adirunke. Yes, it also depends on the volume of data that you're dealing with. So you are doing a great job using Excel at this moment because Excel is actually quite a robust tool for managing data. Now, are you going to be sharing this data? And are you going to be using it for analysis? That's a different ball game altogether. So if you are doing like very little analysis, you could basically use your Excel sheets to achieve what you want to do. So you want to know simple things like and I don't know the sort of data that you have, and again, I'm ignorant about it. But let's say you wanted to know the velocity of people coming to your practice and what days they come in or what times of the year they come in. Obviously, you can use your Excel sheet, right? But then if you're looking at more complex data, it's like, so you're also looking at other factors with regards to your patients, then you might really need to look into data analytics where you have to factor in the times these people come in and other data sources that you're privy to, right? To be able to make more informed decisions. So this is definitely something that you want to listen to. I don't know if I was able to address your concerns, Adironke.
Yes, you did. Thank you very much.
Awesome. Thank you so much.
Sorry, Lade. I don't care. What do you mean by saying that laymen like you? You're not a layman, no, and you're not a laywoman. So you are an intellectual person.
An expert.
And no, I won't call her expert. She's an expert in other things, not. But seriously speaking, Ronke, I think what you can also consider, in addition to what Lade said, is you have other factors like cost. So you're using Excel now, which is basically part of your MS Office suite, right? Which is coming at next to nothing to you as a cost. You're paying, but it's next to nothing. So you're looking at cost because if you have to acquire a database to store the same information, it's going to cost you relatively more. There are cheaper ones, there are more expensive ones. Then you look at accessibility. Do you want a data that is just accessible to you or a data that you want to be accessible to multiple people without you having to start sharing it via email or maybe at best share it on a Google Drive? You want it to be available online real time. You're not going to be able to do that with Excel. Okay, you can use Google Workspace and all that stuff. But again, right? So you need to begin to understand, okay, what exactly are you a single user or is it a multiple user application that needs access to that database in real time? What's the frequency with which you need access to that data and all of that. That can begin to inform. And then, like Lade rightly said, what is the volume of data, right? Because even Excel, Excel, if I'm not wrong, they had increased, and Lade correct me here, they had increased this from the 65 536 rows that you can have in Excel. I think it's way more now, right? They opened it up. So yeah, you can
Yes.
store millions of records in Excel, in an Excel worksheet, but there's still a limitation. Whereas in a database, you're only limited by the storage. It has nothing to do with number of
Mhm.
rows or columns. It's irrelevant, right? It's just storage.
Mhm.
So those are the kind of um, how do I put it, factors you would want to consider. There's no need you buying a Ferrari when you don't even have the high-tech road to ride it on, right? So just use as long as what you are doing right now meets your day-to-day needs, then that's fine. But if you now start realizing that Excel is no longer, meeting what you want to achieve as a business owner or a business user, then you now need to step things up into things like databases, and data warehouses is just another, you know, that's another monster on its own, right? So, but for now, you just need to ask yourself the question: what do you really want to do with the data that you are processing right now? I hope that helps.
Yes, it does. Thank you so much.
Thank you so, so, so much, Mr. Michael. Nobody could have hit the nail harder on the head than that. That explains everything. You also need to look at the volume of data that you're dealing with, and then you can now access which or assess which technology that you require for the data. All right, so we're still on concepts around data ecosystems, data pipelines, and this is something that I work with frequently because as a data engineer, you need to be able to get the data from where it's being sourced or where it's being created to where it's being used. So let's talk about pipelines. A data pipeline is a method in which raw data is ingested from various sources, transformed, and then ported to a data store. So, an example, data lake, a data warehouse, or for analysis or reporting. There are three different types of data pipelines that exist today in our current data ecosystem. Number one would be ETL. So, ETL pipeline, these are pipelines that extract data from various sources, transform it to meet specific requirements. So, you are going to perform cleaning, enriching, any sort of feature, or let's say if you are doing machine learning, feature engineering, right? This is where it's going to occur to meet specific requirements and then load it into a target system like a data warehouse. This is a classic approach for preparing data for data analysis. So, this is a typical method. So, let's say you have some data and you need to solve a data problem. Your management is saying, how can we get more sales, for instance, right? And you have all of this data in all of your business operations and your business units, and you say, we sell ice cream. Let's look at how we manage our inventory and how we manage our human resources so that we are able to maximize profits as an organization, right? So ETL would be a fantastic place to start. So basically, what a pipeline like this as a data engineer would be is you are able to connect to a data source, let's say transactions that your customers do, and then you are able to transform, meaning you are able to take all of those inputs that they take from all of those transactions that your customers have done, and then you're able to make reasonable calculations from it. And then it doesn't really even have to be business. Let's look at meteorological services, for instance. So they're able to take all of this temperature, all of this wind speed, all of this other things, and then they're able to transform it so that they can predict at the end of the day, which is the load. Now, the load is where it's being used, right? So let's say a load is your data analyst, your data scientist, it's your data visualization, or it's just everyday use. So tomorrow they want to be able to tell you meteorologically what the temperature will be based on today's information and information from 3 weeks, 4 weeks back then, right? So they're going to collect all of that information. They will do the transform, meaning there will be some advanced calculations on how to determine from temperature and let's say wind speed what the temperature would be tomorrow, right? So ETL is one example of a data pipeline. Basically, in any type of operation that you have as a business unit, what we're saying is where do you get your data from? And then you're going to transform it for usable reasons, because just getting the data isn't enough. You really need to calculate different things. So, example again, in the meteorological information I use is okay, you're going to calculate wind speed for tomorrow based on today, right? So that would be your transform, and then your load is wherever it is that is going to get to. That's your final destination, and that's where the users are making use of it. Does that make any sense? I'm willing to take questions here before I continue.
Can you please recap it again, please?
Yes, of course. So, I don't care. Can you give me an example of a business concern, and then I might use that one that would fit, if you don't mind.
Can we use retail?
Retail, of course. So we're looking at retail now, and we say um, the data source would be all of the transactions that come into retail. Let's say you are Hudson Bay and you're a retail giant, you sell clothes to people. Now, all of these transactions that come to you in the ETL pipeline would be you're extracting all of that information from transactions that people do. But you also have a historical transactions, right? So you have transactions for today, but you also have transactions from last year. A lot of this data is being collected by your organization, right? Now you want to tell, let's say, management what's going on with profit, right? And so you have to do some little computations. So it's not just about how much sales that you've made at your storefront. Now you want to do slight computation about what the profit is, because some have discounts, some don't have discounts, and some are just, you know, medium discounts. So now you really want to be able to do those transforms on the fly before you load it for management purposes, right? So now that's transform process. In the middle is you trying to figure out, okay, well, for this shirt, we changed the profit margin for this, and for this skirts, we changed profit margin for those, right? And at the end of the day, we've done those complex computations, right? Right before we make the final results that your management is going to want to look at. I don't know. I don't care. Does that make sense?
Yes, it does. So that is the pipeline, correct?
Yes, that is the pipeline. So that would be an example of a data engineer looking at a retail source and then applying those transforms, right? So things about profit, things about sales, things about whatever it is. If you take raw data and then you make any sort of computation on it for final evaluation, that is an ETL process.
Thank you. That makes sense.
All right, awesome. Now we also have the sorry, Mr. Michael. Yes. So we also have the ELT process. This is not common as much anymore, but again, we have to discuss it because the type of data pipelines. Basically, you extract the data from the sources and then you load it to the final destination. So we take it from, let's say, your data lake, and then we put it into a warehouse, right? And then the transforms happen at the point where there's some analysis or some machine learning job. It's not a common practice, but again, we have to discuss it because of the type of data pipelines, right? So basically, what it is, we've extracted all of this data, we've saved it in some place, and then we loaded it, and then we say, all right, machine learning use, you have to clean your data, you have to do whatever it is to make sure that it is relevant to the business solution that we're trying to solve, right? Not too many people do this. It's not a common practice, but again, it does exist. It's a type of pipeline and it's just slightly different from ETL. Any questions? And like the slideshow says, exactly what it is. You take data from somewhere, you put in your data lake, and then from there, you try to figure out how to transform this data for useful information.
Makes sense to me. Thank you.
Awesome. Thank you so much, sir. Anybody else?
It makes sense to me. It's self-explanatory.
Great. Now, the third type of data pipelines, and this is somewhat more common with the age of information that we're in. A lot of vendors handle the data for companies, and so they are able to just do all of the transforms exactly from the source, and then you tell them what data you really need, and so they load it to you. So it's EL, right? So it's a type of data pipeline that focuses on moving data from its source to a target system without performing significant transformations along the way. So an example would be Google Analytics. You're not going to sit down and try to figure out any of the things that Google does for your analytics. You're just going to take everything the way it is. So that would be an EL type of pipeline. Reason being is if Google gave you the data, you would probably not be able to understand it. So they are more aware, they're more seasoned and a more mature organization where if you have data residing in the cloud and then you're requiring it from Google, then EL makes the most sense, meaning it's just basically data that they've given to you after they've done all the transforms, all of the analysis and whatsoever. But also, you could, as a business or as a business unit, have data where you don't need any transforms. So you get some data about your customers the transactions they do, their age, their demographic, that sort of thing, right? And extract and load will be the best option for you in that situation. Any questions?
Not for me.
Awesome. Thank you. We can move to the next slide. So, what is big data? Big data is characterized by its volume, velocity, and variety. Basically, big data is you have a lot of data, and that would be like in the ballpark of like a Google where you have I don't know, quintuplets. I think that's the word of data coming in, and the velocity is every second, right? People search things on their Google search, or people go to YouTube, or people use other Google services, and so they have a large volume of data coming at a large velocity, meaning, and here's the thing with velocity. Velocity really require it does mean you're having so much in such little time. That's the easiest way to describe it. So all of the search data that you put, so every time someone says, "Oh, I need to figure out what's going on today with the stock market," and then you go to Google and then you type it in, you are one of several millions of people doing that. So volume, velocity, and variety. So velocity also just means how much of it is coming in per time. And then variety is people are submitting data as text, numbers, speech, multimedia, videos, that sort of thing. So as a bank, you look at it, what is our big data like? We get all of this transaction information, we get all of these images of checks being submitted, and then we get some video recording from a mobile app from our users. So that's big data. Basically, it's the culmination of all of the data that you get from all of your business transactions. And if it's large enough, then you are dealing with big data. So what would characterize it would be volume, velocity, and variety. And then you also need to require some tools to be able to manage all of that data that you receive. Questions? Can I go on?
Yes, please.
All right, awesome. So let's look at some tools that you would, again, these are things that you would find. Let's say you get a job and you're working at Netflix or Spotify or any of these companies that deal with a huge amount of data, big data. Some of the technologies that you should be familiar with is Hadoop. Now, Hadoop enables distributed storage and processing. Its components, the Hadoop distributed file system, provides reliable storage across a cluster of machines. This is big talk for basically a bank or any financial institution. They deal with tons of Amazon would do 100 couple thousands of transactions every minute, right? They need to be able to store it and process it, right? And so a distributed storage and processing system makes it easier for them. So basically what it means is all of that data is stored in several different nodes, and then the processing of how that data is dealt with is also done with several different clusters of processing units. Let me try and make some common ground with this. So let's assume you cook for a kitchen, right? And then you have to prepare a meal for everybody every day. It makes sense that you don't store plates and forks and knives and cutlery and all of the other things you need in the same place, right? You put it in separate places, and then you have separate place people go and retrieve all of those things for when it's time to service your customer, right? So that's what the idea of big data and the idea of cluster computing comes in. Basically, we're storing it in several different places. So if one node goes down, you have high availability and reliability, meaning that if that node goes down, there's another node that has all of this information, all of this data, and can still service your customers. Right? That's what Hadoop is basically. It's basically meaning that you have all this, and for a bank, for instance, financial information, we're saving all of these transactions in here, here, and here. And if one of these storage facilities fail, we can still reproduce the financial information and still serve our customers. That would be Hadoop. So it's distributed storage, meaning everything is stored in different places, and distributed computing, meaning that the processing to get everything together also is in different places. Does that make any sense? Any questions around Hadoop?
Lade, I think this is gradually becoming like cloud technology class. I think this is even scared to ask questions.
No, but it's good. Here's the great thing about this class. The thing is, when you get into this career, all of these things I've spoken about won't be so scary.
Correct. And you explained it so well, but again, I don't know. Folks, guys, okay, I'm going to call one or two names. So when he's talking about, distributed file system, right? That there's availability across multiple clusters, across geography, right? And there's reliability. What does that mean to you? And there's no right or wrong. So I know somebody here who is not afraid to talk. So Dami, as in Dami Oni, what does that mean to you?
Okay, Michael, I'm afraid to talk. Because this big data thing, that it has gradually become cloud stuff and all that. So
yes,
it's more complex for me now. You know me, I'm a business analyst.
And I'm coming from analyst,
right? Space. I'm still upcoming.
Right. Okay, I'll let you pass. Okay, no wahala. I know you are not afraid to talk.
Yes, and again, I joined quite late, so I'm just trying to figure out what's going on for now. But I know the recording will be made available for us, right?
Yes, it will be. Perfect. It will be on the YouTube channel. Yes. Nonye, what does it mean to you when we are saying data is available across geography, across multiple systems? What does it mean to you?
Well, can you hear me?
Yes, I can. And thank you for responding.
Well, it means that the data is stored in various geographical locations.
Yep.
And so it's also available and it can be processed even though it's available in different geographical locations, they can be processed at the same time.
Correct.
Yeah, and
Correct.
yeah, I think that's what it means.
Correct. Okay.
Correct.
Correct. So very correct. Now, you remember how I said, so this to everybody, that even though we talk cloud, everywhere cloud, that data, I'm coming, Dami, that data is still stored in a data center somewhere. So cloud is no, you're not looking, your data is not in the cloud, though, like you look up where rain comes from. That's not where your data is, right? Your data is still stored in a physical machine somewhere that we can go there, right? And you see it in movies when they say, oh, there's a data breach, then somebody walks into a room filled up with computers, not the way you have your computer at home. There will just be racks and racks and racks of computer processors, right? That's a data center. Why it's said that it's in the cloud is because it's available to anyone who has access to it, regardless of where you are physically. And that just means it's available online. That's what it means. It's just like your Gmail. It's in the cloud. That's why you can access it from where you are. You don't have to go to California, where the data center is, or in Dublin, Ireland, to go and plug in to be able to access your Gmail. That's what we mean by cloud. So when we are saying that it's across multiple systems, across geography, there can be a data center. People in Salesforce, you will also understand. If you go into Salesforce and you will now see where your own particular Salesforce instance, where is the data center located? You can get that information. So that when Salesforce says that, oh, one of our data center in somewhere on the globe maybe went down, maybe there's an earthquake, and that data center, they lost it. What will happen is that all the data in the data processors in that data center is available in another data center in another location in the world. And so for you as a customer, you should not experience a downtime if they do their job very well. Because what they are saying is that what you are using as the end user is connected to multiple computing processors that are located across geography, so that if one link, just look at it like as if you are living in a compound and you have a central hub that is connected to all the rooms in that compound. And each of those rooms has the same dimension, the same facility, the same everything. So if one room goes down, it's not a problem. All the other rooms have the same facility, the same capacity, and the same processing power. And you, as the client, as maybe in a hotel, it should not mean anything to you, right? They just move you to another room seamlessly, and you should not even experience whether you were in room A or room B, because everything is exactly the same. And that's the concept of high availability, which is what he's talking about. I hope that helps.
In fact,
do you still
Mr. Michael, I can't explain this better than you. I'm telling you.
But anyway, thank you, Lade. But it just makes me laugh that I think we are going beyond data analytics here now, right?
No, we are in the topic of data analytics, and you've explained it in facts. Oh my God. Oh my God. Thank you so much.
No, you're welcome. I know Dami had his hand up. I didn't care, just a
yes,
minute.
yes. I just wanted to. I mean, I didn't really know that was what you were asking, but I guess you've already mentioned everything. So we have data stored in the cloud. You can access it anywhere. I have my company running in Nigeria. I'm in Canada. I can access what they are doing right here, online, real time in Canada, because it is stored in the cloud, right?
Correct.
So I mean, I guess I didn't know that was what you were actually asking. Yeah.
Okay. No, thank you. Okay. Ronke.
Yeah, thank you very much. Now, you just struck something interesting in with that explanation you gave about, data, how it's stored, and making sure there is no interruption. This is the question, and it might not be related to what Olalade is talking about. I think it's interesting to me. Two questions actually. Are there regions of the world that are more prone to data outages or attacks? And if yes, would you by chance know what these data center owners or data centers, as it were, how do they mitigate against data loss? So let's say, for instance, my data is in Michigan. Would they back my data up in California, for instance, or in Beirut? How do they make sure, even if they, because you talked about replication, making sure there is no down, they just move me from one room to the other. How does it work? It might be out of scope of this of this teaching, but I think I'm just interested to know how it works.
Lade, hold on before you respond. John, do you mind to chime in? Again, just asking. No, John is short selling himself.
Ogama, please answer and let's move it forward. I'm learning too.
Oh my goodness, John, yeah, no, that one has come.
But truly, so the thing is actually just like you stylishly mentioned, Ogama, right? Is kind of out of, yeah, I think it's okay to say that, kind of out of scope of data analytics, right? Because what we are talking about now in terms of the management of the data, they are two separate things, right? I think previously I pick one of those words, right? If whoever are the people who structure the data management, if they do the right thing, right? So we've talked about database. So it's in the past that you have a physical location. Today, most people don't even know where the database is stored, except of technology experts in that field, that you want to know, okay, is it this country or all of that, depending on how close it is to, because that also matters when it comes to that aspect of technology. But to answer your question, so the standard is that you should have a failover, meaning you replicate in real time. Is what the bank do, or it's even general, right? In case one fail, it should automatically loop to the next. So your one database is mirroring the other. So it's not just stored in one place in case of anything happens, earthquake, all of those things, natural disaster that is beyond the control of anybody, right? So we cannot exhaust it really, because that is a separate field on its own, right? But for the knowledge sake, let's just know that, when you have your data stored someplace, it's always good to have a backup. In the past, we all have external drive, all of those things, which that also in a way is limited, especially back in Nigeria, there was a client I managed there, like I personally asked them to buy, those days terabytes is the new normal, they bought the new terabyte, and when they had issue, the same terabytes, the server could not even load from the drive, So, but the reality now, when it comes to cloud computing, data management and all of that, is even your server can be stored in somewhere in North America, and the failover could be somewhere in Australia, or where the time zone is even different, the topology, the temperature, all of those things, just for the user to have good experience, good access to their data. So, but really, it's a separate thing, but it's just good to put that there in terms of the knowledge of how it works. Thank you.
Thank you, sir. You see, Lade,
Thank you, sir.
Anyone here. So people are hiding in the.
I know there are so many people that are much more knowledgeable. So that's the great thing about this session.
There are people that can check me too here.
So thank you so much, John. In fact, I can't have given a better response to it. Thank you so much, John. Thank you so much, Micah.
Sorry, I have a question.
Yes, sir.
So this cloud computing that we've been discussing just now.
Mm-hmm.
So my question is that, we've always had data stored, like our Gmail and all that. We can access our data from anywhere in the world. But my question is that, has cloud computing always been, like, has it been always available from time memorial? So where I'm going is that 10 years ago, 15 years ago, cloud computing was not the in thing, right? We were not hearing it. It's just like maybe 5 years ago or even more, if I'm not wrong, that we started hearing a lot about cloud computing. But where were all those data stored back then? I know Mr. John just mentioned he had a client that they stored his data, their data in a flash, in a terabyte. But does it mean that back then, let's say I can open my Yahoo or my Gmail account, I could open it in Nigeria, and when I get to US, I can still open it, right? Where were all those data stored back then, if not in the cloud?
Okay, so I don't know if Mr. Michael or Mr. John want to go ahead, but I do have an explanation for it.
Yeah, you start. You
okay,
please.
Oh, all right. So Olu Damilola, thank you so much for your question. That was a very, very important question. The thing is, the idea of data was people didn't even know what to store, starting from, let's say, 1990s or even in the 80s. But some people had some foresight and said, let's store some of these things for posterity, right? So like time series data, and I'll use this as an example, is people that worked in finance, let's say stock market, they realized early on that whatever you're going to predict in the future was based on what you have received in the past. So those sorts of people were keeping data in financial institutions. So finance, for example, they were already keeping all of their transaction information from all the way back as soon as they could retrieve it, right? And they were keeping it, whether they were storing it in um I, I forget the word, is book. They write it in books, but I can't remember the word for the books that they write it in, right? So they wrote all of those figures, right, inside the books. It's the same thing with any other data. Archaeological data, you find people prehistorically, they'll record all the things that they went to a site and they will write things down. So people have always been writing data, right? It didn't start today. What we're saying is data is important now is because we figured out that we have more important uses in the future. So I'll let somebody else take it over from here. Thank you.
Anyone else wants to chime in? Okay. Before I go ahead, I don't know. Quick one, Lade. I know that plans to demonstrate a use case. I'm not sure how much that would take. I'm personally, I'm looking at timing here. Ideally, we should be wrapping up our session for. So I'm like, would you rather have us just carve out one day? I don't know when that will be, where we just come in and do the use case, so that we don't kind of just rush over it. And then we can wrap this up. Or what do you
think?
Okay, so what I would do is I would also defer to the audience that we have today. Because
last year,
what?
Yeah, is it somebody else? Okay. All right.
Okay. All right. So what I can do is this demonstration is not supposed to be some sort of tutorial on how to use the tool.
Correct.
But it's supposed to show you the extent to which you can use visualization tools, whether it's Tableau, whether it's Power BI.
How long
whether
will
it's
it
Google.
take you to do that, though?
Yeah, I say 15 minutes, maybe. I'll rush over it.
I'm thinking,
normally it should be taking 30 minutes, but I can rush over it in 15 minutes just to show.
So I'm thinking we can throw that in and then we can come back after the fact. And anybody who wants to stay, we can keep answering questions as you go. But so I would say, Dami, hold that thought, and then we'll come back to it. But if you don't mind, Lade, to just, because I think this is the second to the last slide, just get through, and then let's go into the data visualization. And then we'll come back and do Q&A for anybody that wants to stay.
Of course.
Okay. Thank you.
God bless everybody here on the call. Yes.
No, so you can go on with
all
Hive
right.
and Spark, and then keep going.
Okay. Yeah. So I was just trying to describe Hadoop. Hadoop basically is distributed storage and processing. You have several computers working on saving the information or all of the data, and then you also have several computing systems that are responsible for processing all of that information, whether it is for operations or whether it is for reporting. Hadoop has the full structure for it. All right. And then there's Hive. Hive offers a SQL-like interface for querying and managing data within Hadoop. Basically, it's just like you can add data, you can remove data, you can update data, you can delete data. Really, that's basically what Hive is, and it connects to the whole Hadoop system, right? And then you have an interface where you can use SQL to retrieve data from it, or maybe update the data or delete that sort of thing. I'm just rushing through this slide, by the way. And Spark. So Apache developed Spark, and it's for the same reason. It's for cluster computing systems. Basically, let's say you are a video game manufacturer, you have all of this data coming to you, and then you need to be able to process who is the top gamer, right, in your system. Spark would be a good way to go about it. Basically, it allows you to program all of the complex calculations that you want to do and put it in clusters, and that way you are able to achieve the results. So I just ran through what's the big data and all of the different tools that the big data offers.
And thank you so much, Lade. So for folks, those of you that are, again, within the Salesforce ecosystem, Hive will be something like Salesforce Inspector, right? That is to Salesforce, which is just a funky SQL interface for you to query data from Salesforce instance. Okay. All right, let's keep going.
Awesome. Now, tools being used in data analytics, like if you've have some interest in data analytics, here are some tools that you might find useful in your journey to be like a data analyst, or maybe you're a data scientist or a data engineer. Spreadsheet applications like Microsoft Excel and Google Sheets. Basically, Excel is a way for you to store tabular data. It's a fantastic tool, especially if you're a data analyst. It means that you are able to save all of the data that you require for your business operations. And then from there, you're able to make some useful information or decision making from there. And visualization tools, example, Tableau, Power BI. And then if you are going right into the weeds, then programming languages like SQL, R, and Python, meaning these are the tools that someone who is in data analytics, whether it's a scientist, whether it's an analyst, or whether it's an engineer, these are some of the tools that you might be working with. And these are the tools that you should be familiar with, really, going forward. All right, so careers in data analytics. Let's start with a data analyst. I mean, like we could use a typical story of an organization and say, what does a data analyst do? They collect, process, interpret large data sets to uncover meaningful insights and trends. They use statistical and computational techniques to clean, organize data, identify patterns, and develop data-driven solutions for complex business problems. That's a lot of grammar, really. Let me tell you what a data analyst does. So let's look at an enterprise example, for instance. You have a data analyst that is working in Google, for instance. Their whole thing really is give me the data and let me be able to look through it and provide some visualization so you can make a decision as management. So let's say the business problem for Google is how do we get more people to view videos in YouTube? So they think about it and they look, let's think about it and say, we don't know. Now, the idea is the data analyst is going to look through all of the information provided by data scientists, really, right? And say, these are the things that affect how many people watch our content for this duration, so we can increase it for profit, right? So a data analyst is going to look at all of data being supplied to him by a data engineer and say, let's look at all of the things that matter. Okay, did we show this thing at this time of the day, for instance, or how long, right, should we keep our ads, right? Those are things that a data analyst would normally look through. Okay, so that's the data analyst side of it. His job is to be able to take all of the business problems and then say, okay, well, this is how we analyze it and this is what we should do next. A data scientist is like any other scientist in any other field of endeavor. What they do in this entire data ecosystem is you give us a problem. How do we increase viewership on our platform? Let's say Google. Again, we're still using Google example. How do we increase viewership? And a data scientist says, oh, let's look at all of the different variables that might affect viewership. So what time of the day are these people viewing our content? What type of content are they viewing? And then how do we relate it with other people that view similar content, right? So a data scientist is going to be able to bring all of the data points together and then trying to figure out how all of the data points solve the problem, right, that the organization has. Now, I'm going to give an opportunity for people to ask questions here because sometimes I feel like I talk too much. So, any questions, please?
No, let's keep going, Lade. You
All right.
you do your thing, and we'll leave the questions till the end. You don't mind.
All right. Awesome.
Yeah.
So, like any other scientist in any other field of endeavor, what they do is they figure out what the problem is. They make a hypothesis. A hypothesis is a guess, basically saying, well, I feel like this affects the outcome. And then a theory comes out of it. And then it's based on that theory that people go ahead and work on. So let's say we sell ice cream. Let's look at the time of the day people buy ice cream, the sort of people that buy ice cream. That would be a data scientist's job, basically, to try to figure out how all of those different factors affect the number of sales that you make at the end, right? And then the data engineer's job, right, is to make sure that all of this data is available to the data analysts and the data scientists. So I'll go again. A data engineer builds and maintains the infrastructure for organizations to collect, process, and use data. Very important. So his entire job is to make data available from the source to the destination, whether it's a data analyst or it's whoever, data scientist using it for machine learning jobs. His job is to make sure that all the data is obtained, it's cleaned, and it's made prepared for all of everybody else that is using that data. So they design, construct, and manage complex systems and frameworks that enable effective data utilization. And the key word here is data utilization. So for the data analyst that is doing some visualization work, the data engineer is the one who is creating all of the systems, all of the processes, cleaning the data and making sure that it's okay for the data analyst to be able to give a final result. Same thing that he does for the data scientist. Historical data, he must be able to get it from the source, get it prepared enough so that this data scientist is able to identify patterns, trends, and is able to bring out correlations so that they can develop models and algorithms. Now, there's one other person here in careers in data analytics, is a data architect. Now, depending on the size of the organization, you have a cloud architect, but you can also have a data architect that is responsible for determining the infrastructure required for you to be able to get your data from the source to the destination where it's being used. That is my spiel for careers in data analytics. Any questions, please?
So I guess and thank you so much, Lade. So I guess for beginners, I think data analyst is where you want to focus on, because that's like low hanging fruit, right? And then as you go into data analysis, you can now decide where you want to go from there. So don't overthink it. If you really want to get into this space, most likely you're just going to start off as a data analyst. Is that correct, Lade?
Yes, yes. But I mean, you could also look at courses or online courses for data scientists,
Correct.
right?
Yeah.
I mean, if you're interested in looking at a problem and trying to solve it, then 100% a data scientist option for you. And if you want to be more back end, where you want to maintain and develop the infrastructure for data from source to destination, then a data engineer is more career path for you. Thank you.
Thank you. So